Okay, 4.3, for the circuits shown in 4.3 using ideal diodes, find the labeled voltages and currents. Okay, so what you can do here is you could assume one or both of the diodes on and then analyze the terminal voltages and how they're simultaneously existing with the voltages across each diode, and see if that lines up physically with the operation of an ideal diode, right? So if you assume both are on, or if you assume one is on and one is off, what are the voltages that end up being across each diode, and are those do those match up physically with the ideal diode's on or off characteristic? So you can try to solve it yourself, or I'll do it for you. So let's see. Let's say I'm just gonna do this on the fly, okay? So let's assume that this diode is on, right? If this diode is on, this whole line is gonna be at 1 volt, right? And then this 2 volt would be greater than this 1 volt, so this would also turn on, right? This would also conduct a forward current. Okay, now if that were conducting a forward current, then this would short circuit, and in fact, so if this short circuits this 2 volt, would now replace this 2 volt source. So it just kind of took over. Now you can go back and check here. If we have a 2 volt source here and a 1 volt, a 2 volt node voltage here and a 1 volt here, then the greater voltage being here, that results with a current traveling in this direction, right? But that diodes can't do that. So this is the configuration or whatever. So this voltage is going to be 2 volts, and this current is going to be 2 minus -3, which is 5 volts, divided by 2 kiloohms. So like that. Let's do it for the next one, okay? So we can assume this is going to be on, and if this is on, then it's going to short circuit, and this would be 1 volt, right? And then let's look at that. If that were the case, then this 1 volt would be smaller than this, and a current would be traveling in this direction, right? And that's not allowed, so that would be off. And if it were off, that would all work out, right? So let's look at that looked good to me. That looked good to me, but because I'm doing this on the fly and gonna check what would happen in this case. Let's assume this one's on. If this one were on, then it would short circuit, and this would be at 2 volts. Now, if this were at 2 volts, then that would be greater than 1 volt, so this would also conduct. So if it conducted and it short circuited, then now this 1 volt would become 1 volt, which is the case we just checked, and it was all legally working, So this voltage is going to end up being 1 volt. So this current would be 3 volts minus 1 volt is 2 volts, divided by 2 kiloohms, which is like 2 milliamps or whatever. There you go. That's it.